Fast Copy is a unique product. Like other FastCam products, it's not CAD. In fact, Fast Copy was invented as a mathematical tool to recreate engineering parts. If old drawings are digitized by user skill, they can be better, not worse, than the original. Each button on the 16-button cursor has a function. The first 7 buttons are mathematical. The first is a line. You could do everything with this, but a complex curve, even an arc, would come out poor. So you need an arc. Button number 2 is a point on the arc. Circles are special constructions, and you can define a circle completely with 3 points. Some arcs are special too. The first one is blended into the next line. This is button number 4 at the blend point. Then you may want to blend smoothly with the last movement, but not the next. This is button 3. A fillet is very special. This is common in all manufacturing. A blended radius between 2 lines. It's so simple with Fast Copy. You do not have to pick the blend point. This is done for you in the calculation. So we have the basic idea. Now, to put it together. The first thing to realize is that we are programming an NC machine. You have all the logic of cutting, insides before outsides, entries and exits, and cut to the left or right. First, you need an accurate pen drawing. Never put heavy weights on the digitizer surface. If you analyze an engineering shape, it's made up of the basic geometric elements of points, lines, and arcs. Full circles are a special type of arc. Of course, you could do it all with lines, but you would need thousands of them, and the result would not be very usable and the NC program immense. This would not make for smooth cutting. So looking at the ink template, you can see the elements. Here we have drawn entries on the 2 holes and on the outside, and we will write our NC program. There are some preliminary questions. You can recover an old digitization. You can scale the drawing, or set a new origin to digitize parts much larger than the digitizer. First, show the area on which you wish to work, bottom left to top right. You will now see how the screen follows the movement. The idea is that you can operate everything from the puck buttons without the keyboard. Set the curve to left with button 8. Switch to cutting with button 7. You will see the screen change. You can have many processes, including line marking and drilling. To digitize the circle, pick 3 points with button 6 and the circle appears. Of course, like other constructions, it cannot appear until you have selected all 3 points. Now button number 7 to turn the torch off and wrap it to the next circle and repeat the sequence. Note carefully that the sequence of the points gives the direction of the circle. With curve left, you must pick the points in a counterclockwise direction for a hole. Now to cut the outside. Button 7 to turn off the torch and go back into rapid mode. Across to the outside profile, we will cut in a clockwise direction using a series of button 1 presses for lines. Use button number 5 to pick up the fillet. The number 5 has to be on the arc. Exactly where is not critical. You see how fast this is and how accurate. Here we press button number 3, an arc blended with last. Another line and then an arc blended with next. Now, a simple run home with a series of lines and fillets. Remember, you do not have to accurately pick the blend points. The software finds this for you precisely. You can output a DXF file now, but the real intention is to output your NC program and check it. To do so, press button number 3. The software is set up to output SE code, but you can output for a vast number of NC languages. The setups are identical with other FastCam family products. Using FastPlot, you can check your NC code automatically, even stepping through the movements. The NC is on the right. You can see the directions and that the torch is on the correct side of the cut at all times, or the part size will be wrong. Inside for holes, outside for profiles. Easy? We hope so. Fast Copy, an essential tool for many. All the simplicity of optical with the productivity of NC.